Hello, everyone. I welcome you all to the sixth session of JCL programming. Till now, we have covered a lot of topics. So this is sixth session. So this is the agenda for the sixth session. So first we will be deep diving into what we have learned in the last session. So it will be a recap session. And after that, we will be discussing what are the written codes and system completion code we are available in the JCL programming. So for example, whenever you are submitting any job and after that you get the message on your screen, if your job executes successfully, then you get the written code as 0 and sometime as 4, and if your job is not completed successfully, then you get the written code from 8, 12, 16, another value. So that is regarding the written code. And also we have the system completion code, which is regarding sometime we get the abandoned messages due to program error or data error. So that is regarding the system completion code. And after that, we will be discussing the restart parameter in JCL programmer. So whenever your job bend or whenever any step fail, what needs to be done, whether we need to restart from that particular step or whether we need to restart from the starting or the first step of the job. So that is regarding the restart parameter. And after that, we will be discussing what are the JCL condition statement we have. So what is the significance of that COND, which is cond parameter, and how you can use that parameter in your JCL programming at job level. So let's go. Okay, so this is the last session recap. So in the last session, we have discussed what are the record format we have. So in the JCL, whenever we are trying to create a new file, so we provide the record format. So there are five types of record format we have. First one is the fixed, that means F. So fixed is basically fixed length records, and those are not block. And also we in the last session we also discussed one diagram where so by using that diagram it the picture is very clear how you can define what is fixed block. So basically fixed block is the record that are having fixed length and those are combined in the block. So block size is equals to whatever the block we have into the whatever the record length we have for that particular record. So we have fixed, then we have fixed block, and after that we have variable. So which is regarding the when we have the different types of length for a record, then it is a variable length because the length is not defined, length is not fixed. So each and every record is having different or variable length. And also there is one term which is record descriptor word. So whenever we are defining any variable length record, so at the starting of the record we will be having the record descriptive word, which is RDW, which is of 4 byte. And after that we have variable block. So it is same as a variable, but we are combining or we are using the blocks for that variable length record. So in here, uh, along with record, we also have RDW for each record, but for the each block we also have the BDW, which is block descriptor word, which is also 4 byte long. So whenever you are using VB, so we'll be having BDW, we will be having RDW. Then after that, our record length will start, and it is regarding the VB, which is variable block. And after that, we discuss which is undefined. Undefined is record that are not defined, or basically there is no internal structure for access method. So that is regarding the undefined. So we have discussed this record format, and after that, we have discussed some example. And after that, we discuss what is how you can code the DD statement for the in-stream data set and how you can code the DD statement for the sysout. So for in-stream, we also discuss like there are two method where first one is the asterisk one and the next one is data. And after that, we also have a DLM. So we discuss the examples. So whenever, if for example, in your COBOL program, if you are writing any accept keyword in your COBOL program, that means you are expecting value from a JCL. So in that case, we in sysyn parameter, we pass the value. For example, for any particular employee ID, you want to read something or write something into another file. So we provide that employee ID in our JCL as in-stream data using DD statement, and that data will get write to the spool, and our executable program will catch that data from the spool and execution will start. And regarding sysout, so whenever you are working on any report, for example, report program, so sysout plays a very important role. If you want to write any report to any particular file, then we need to provide that file in the sysout. Or also, if you want to provide any message class, so that it will use that message class for the sysprint. So that is regarding the sysout, and this is just a recap for the last session. Okay, so in today's session, the first topic is what is written code or condition code. A step written code or just a written code or a condition code indicate whether whether a job step ran successfully. So if you hear the term step written code or condition code, all are same, and it indicate whether your job step ran successfully or not. If this step end normally, then written code is usually 0. And if the step does not end normally, the written code can have value from 1 to 4095. The program that executed during this step determine what the written code will be and what it represents. So most of the times all IBM compiler, link editor and utility program follows the same general numbering conventions. So for example, if written code is 0, that means it indicate that that particular step runs successfully, there is no error, and program executed successfully, or that step is executed successfully. If we have a written code as 4, then that indicates some minor errors were encountered, but program was able to recover from them. So most of the time you will also encounter a written code as 4, but your program will get executed, or that particular job will get executed. Why? Because there are some minor errors were encountered, but program was able to recover from them, and that's why your program is executed, and that job whatever the job step is executed. For instance, compiler will typically rerun return a code of 4 if the program source code generated any warning messages during the compilation. So basically it is regarding the warning messages or any minor error, and but program was able to recover from that error. So that's why whenever we get condition code or written code as 4, then also our program gets executed, or that step get executed. So that is regarding written code 0 and the written code 4. Written code 0, that means no errors were encountered, your job step completed successfully, all good. And if you're having the written code as 4, that is also accepted, your program will get executed, your job step will get executed, because we are having minor error and our program was able to handle or recover from that. Okay, so next one is whenever we get the written code as 8, that indicate program encountered a problem that prevented it from performing a successful execution. So for example, if you are getting a written code as 8, that means you are having some major error, and our program is not executed, that particular step is not executed. So we need to check why we get the written code as 8, and we need to check it in messages, pull messages, JCL messages, and from there we get, okay, this is the cause, and by using that cause, we can find the solution for that particular issue. And when we get the written code as 12, it is like in 8, but more serious. So 8 is also a problem, and 12 is a very serious problem. And written code of 16 indicate that the program encountered a serious error and was not able to continue. So basically, whenever you get 8, 12, 16, those are the serious issues, and those are the serious errors that we need to check why our program is not executing, and why our program or that particular job step is getting written code as 8, 12, or 16. So what is the significance of this written code or condition code is, so that will tell us, okay, your job step is executed correctly or not. If your job is successful, then you get the status code 04. That means, okay, everything is fine. We were able to run that or execute that program and operation is completed. And if we get 8, 12, 16, that is something is not correct in that program or in, so that's why written codes and condition code plays a very important role whenever you are doing the JCL programming, because that tells us what is wrong with that program. Okay, so these are the typical types of condition codes in JCL. So that we have already discussed in previous slide, that a written code 0 means program ran to successful completion. And if we get the written code as 4, program encountered a minor error but was able to recover. So we were getting some minor error, but our program was able to handle those errors, and we also get some warning messages. Our program was able to recover from that. So that is regarding the written code 4. Then we have written code as 8. Program encountered a problem that inhibited successful execution. That is where the program is not correct or file something is happened. That's why we are getting that written code 8, which is an actual issue, and program is not executed, step was not able to complete. When we get 12 or 16, that is same, the program encountered a problem that uh, impacting the execution of program and indicate the some more serious error than written code 8. And same goes with the 16, encountered program is encountered with serious error and wasn't able to continue. So when you get 04, it is okay. When you get other than 04, something is wrong with that particular program or that particular job step. So we need to check that. Okay, so basically when you are submitting any job and your job get completed, on your screen you get this message that this step was executed and condition code 00. When you get 04, it is also accepted. When you get 8, 12, 16, then we need to check. So there are different languages, programming languages that issues the written code. So in our COBOL, it is just move written code to the written code values. So whenever you are working in written codes in your COBOL program, so that is the syntax that most of the time we need to use. And also there are other programming language as well where written code plays a very important role. So for our perspective, we just need to focus on COBOL. And if you're working on PLI or a similar language, then you need to check that as well. So that is regarding the written codes 0, 4, 8, 12, 16 and significance of written code. Okay, so the next one is what is system completion code? So we have written code or the condition code, and we also have some system completion code. As you can see, if job ends normally, the system completion code is 00. Otherwise, the system completion code is generated in JCL message output and consists of an S followed by 3-digit hexadecimal number that indicate the reason for abnormal termination. Okay, so whenever you are facing any issue with program or any abnormal termination of your job, then you will get a message on screen. That is something, first letter will be S, and after that you will have the 3-digit hexadecimal number, and also we get the reason code as well. And many of these append codes also include an additional reason code to help further explain the source of problem. For example, if a job has a system completion code as S0C4. So basically in our programming language, we called it as a SOC4. Reason 4, it indicates that program abandoned because of protection exception. More than likely, the program tried to access an array table with invalid index or subscript. If you're having any issue with the program, or if you're having any issue with the file or module or data, then sometimes we get the abend messages, and in that abend messages we get the messages on a screen in the form of S. Then we have 3 value as a hexadecimal number, and we also have the reason code as well, which indicate, okay, what is that reason. So based on that error message or the reason code and the completion code, you can check, okay, what is the actual issue with that program? Is there any subscript index issue? Is there any data issue? Is there any file issue? So that's how you can reverse engineer and you can check what is the issue. So here the output line include information like job identifier, job name, step name, and the append code and reason code, all of which help you track down the cause of the problem that we have already discussed. So on your screen, you get the information of job name, step name, and you also get the append code, reason code, and all that information is very necessary so that you can track down the cause of the problem. Okay, so these are the different types of system completion code in JCL. So system completion code that we discussed. So at the starting, you will be having S, and after that, you will be having three hexadecimal values. So here we are only having three hexadecimal values because S is common for all. So when you get S triple zero, normal completion, the job ended successfully. When you get S0 C4, that means protection exception. The program tried to access a storage area other than its own. And it happens when storage array is accessed with an invalid index or subscript. So this chart is very useful whenever you are working on JCL programming. And if you get any event, you can verify this chart. Whenever you get SOC 4, then you can check, okay, so that is because of we were having some issue with index of subscript. But when you get the reason code as 10, then there is a different issue. When you get the reason code as 11, then there is a different issue. So basically, we also have the code and we also have the reason, and based on that you can filter your issue, and based on that you can check what is the actual solution for that issue. So most of the time, whenever we are working on any project, most of the time we get SOC 4 and SOC 7. So because of here we have this SOC 7. So S, then we have 0, then we have C, then we have 7. So it is basically the invalid data used in the calculation. So most of the time in COBOL program, you are doing some calculation, you are using compute, you are combining different types of variables in the calculation. And most of the time it happens that you are doing some operation or you are using any invalid data in the calculation, and that's why we most of the time get this SOC 7 because of data error. And also we are having 122, triple two, 322, 722. So you can just stop the uh, recording or stop the video, and you can just screenshot this information or write that information in your notebook so that in the future, whenever you get any abandoned message, so that you can get the information, okay, so this is what the actual issue is, and you can work on your issue. So here we are having some examples, the completion code message in JCL output listing. So here we are getting the append as S806, and we are having reason as 4. So that means we are having 806. This is, so what is the actual issue? Program not found. The system could not find the program module to execute. So whenever you write the JCL, you need to provide the program name, which is the correct program name. And also you need to provide the library of that program where that program is reside. So we need to take care of those things, and whenever we don't use the correct name or correct library, then we get this kind of abandoned messages. So this chart and this information is very useful. I follow this information in my project task or any task which is regarding the JCL programming. So firstly, we have the completion or the condition code, then we have the system completion code. Okay, so now we have covered the what is the written code and how we need to check that written code and what is the significance of written code, and also we check the system completion code whenever we get any update messages. So we have covered that part. What is the next process? Okay, the next process is a restart of the job. For example, your job is having different n number of steps. So in if you're working on any project, then there are some jobs that are having 200, 300, 500, 400 steps. So any step is having any issue because of some whatever the reason, and if that step is not executed, then our job get failed, and we need to check, okay, so for that particular step, for example, step 10 is having some issue, so we corrected that issue. The next question comes, from where you need to start the job. So basically, that is what the restart step. So the job may terminate before they complete due to a program or system error. In either case, it is possible to restart a job at a point other than at the beginning. To be specific, you can restart a job from designated step at a step restart, or you can restart a step from a checkpoint within a program. A restart parameter of the job statement which lets you restart a job when one of the job step has failed. So yes, I already explained to you. So if that particular step 10 is having issue, you corrected that issue, then the question come whether we need to restart the job from step 10 only, or whether we need to restart from that starting. So it is basically depends on whatever the operation you are doing. If you're having any file that are useful for step 10, and so that's why we need to restart from the beginning. And if there is no any dependency of earlier steps to this step, then you can start from that step. So basically it is depend on the business operation and business logic. So whenever you are working on any JCL, and if you get any issue and you need to restart, so you need to understand the business logic of that particular JCL, how that particular step is dependent on other step, and based on that you can restart the job. So if you're working on your project, so in the project we basically have the restart library. So at the start of the uh, job creation, we basically create the restart library where we write the whatever. If for example step 10 is having issue, then we write, okay, the restart step for that particular step is step 10. And there are also other steps. When that step get issue, then we start the job from the step 8, for example. So we are starting our job from the 2 step earlier because there is dependency of those 3 steps. So there are some dependency of JCL steps. So we need to understand that. So in when you are working on your project, you need or you basically follow the standard process when you need to create the restart libraries for all the job steps that you have created. So normally you specify the job step name where you want to restart the job, but you can also specify a procedure step name if the job calls procedure. Yes, it is totally depends on your operation whenever you are using any procedure. So we need to provide that procedure step name. And if you code an asterisk in the place of step name, the job will simply start at the first job step. The because the step was not specifying restart at all. In a coding, in coding the restart parameter, keep in mind that you may not always be able to restart a job at a job step that failed. That I already explained. Sometime we face a problem, or sometime we face an issue. Always keep in mind that you are not that case may happen that there is some dependency of that particular job step to other steps. So just check. So that's why that's because the step may depend on references or temporary data set created by previous step. Okay, so that is what we have discussed in the last slide. So whenever you are having any job step uh, failed, so we need to check, is there any dependency, is there any condition statement attached to that particular step? Because most of the time we also have the condition statement in that as well. So we need to check, and is there any temporary data set created by previous step that needs to be used by that particular job step? So we need to check the dependency whenever you are using the restart parameter for the rerun of that particular job. For example, suppose you want to restart a job at a step that was executing a report program when it failed. However, the report program reads in a sorted temporary data set created in a previous step. Since the sorted file was temporary, it was automatically deleted when the job abandoned and now doesn't exist. So it is very good example. So you are working on any report program and something happened and your program failed in that particular job step. And in earlier steps, you have created some temporary files and your job is failed abnormally and that's why your file get deleted. So in this case you need to restart the job at this step where the temporary data set is created. Also be aware that you need to delete any data set the job step created in the previous run before restarting. So yes, it is a very important thing that you need to keep in your mind. Just check whatever the dependency you have for that particular step, and also you need to delete any data set that job created in a previous run before restarting. In general, you add a restart parameter to the job once it failed and then resubmit the job for processing. However, some programmer like to code restart equals to star in all their jobs. Then when a job fails, they simply replace star with the values needed for the step or the checkpoint restart. But I'll suggest it is a very good practice that whenever your job is having some issue, then you mostly write the restart equals to whatever the step. So that is what I used to follow, that whenever I'm having any issue with the program, I usually write that restart equals to whatever the step name. But there are some programmers that like to code restart equals to star, and whenever they want to change that, they just change that with their particular step. Okay. So this is the syntax of restart parameter of a job statement. So here we have restart equals to as a keyword. Then we basically have three options. First one is asterisk, specifies the system is to restart the job as at the first job step. Yes, so whenever you are doing asterisk, it is just checking the first job step. And the next one is the step name, specifies the system is to restart the job at the beginning of the name job step or at the checkpoint within that job step. So for example, your job is failed at step 10, then you need to provide that particular step 10 in your restart statement so that when you rerun or resubmit that particular job, then your job will restart from that step only. So very important thing that you need to provide the correct step name, and also you need to check the dependency of that step, that program with other steps that you have completed before. The next one is the procedure. So that specifies the system is to restart the job at the beginning of the name job step of a catalog procedure or at a checkpoint within a job step. Step name identify the exact statement that calls the procedure, and proc step name identify the job step within the procedure. So it is basically regarding the procedure. And so there are some example here. Here you have the restart as equals to step 3. That means you are restarting your job from that particular step. And here you are having step 3 and you are giving some more information. So that is the syntax of the restart statement. So just keep in mind whenever you're using restart, check the correct step name, check the dependency. Is there any data file, temporary data file created before that? And okay, so next one is the what is condition parameter in JCL. So whenever you're working on JCL, there are also condition parameter that will help you to, based on some written code or based on some condition, you can also manipulate the execution of any job step. So the condition parameter allow you specify condition that will allow a job step to execute. Especially it allows you to check written code from earlier steps so you can decide whether to execute the current step. You can code this parameter on either the job or exact statement depending on whether you want to specify condition that applies to each step in the job or only a single step. So yes, you can have the condition parameter on job, and you can also have it on the exact statement. When you specify the condition parameter in job statement, you specify the conditions that cause the job to stop processing. For example, suppose you have a job with several steps, and if any of this step is having issue, and basically if any step issues a written code of 4 or more, the job should stop processing, bypassing the remaining steps. So if you write the condition, so whenever you get any condition code or written code of from any step as 4, then you should stop processing the job, and you bypass the remaining step. So that is your condition. So how you wanna write that particular condition in your JCL? So in this case, condition parameter will be this. So cond equals to, in bracket, 4 comma le. That means if 4 is less than or equal to the written code issued by any job step, the remaining job step are to be bypassed. So that means if you are getting any written code from any job step, so your condition parameter will check, is that particular uh, condition code is less than or equal to 4. If not, then it will bypass that particular step. For example, if the written code is 8, the remaining steps are bypassed because the condition is true. In contrast, if the written code is 0, the condition is not true, so the job continues with the next step. So here, whenever you are getting the 0, that means 4 is less than 0, which is a not true condition. So that's why your job will executed and it will continue with the next step. Whenever you get the written code as 8, so 4 is less than 8. That means yes, your condition is true. That means you need to stop your execution of that job. So this is how you need to check your condition. If you are getting written code as 0, so that means 4 is less than 0, which is not true. That means your condition, your job will get executed. Whenever you are getting written code as 8, you need to compare 4 is less than 8, which is true. That means your job will bypass. So to be honest, many programmers find this condition handling logic very confusing. So as you look at some of the example that we will be discussing in the next slide, remember that the value you code in the condition parameter is compared with the actual written code using the relation operator you specify. So whatever the condition you are specifying in that condition parameter, that will compare that value, whether whatever the operator you are using, less than, equals to, greater than, all that thing, with the actual written code that will be generating for that particular job step. If the relationship is true, all the remaining job steps are bypassed. In other words, the condition parameter specifies not the condition under which processing is to continue, but rather than under which uh, processing to be determined. So just keep in mind, whatever condition you're using, just keep in mind, if the condition is true, that means it will bypass. If condition is false, that means it will continue. Okay, so here are some example, the syntax of condition parameter in job statement. It is very easy syntax. So you just need to provide cond equals to value, that we are having some good example here. So here are some condition operator that we use in day-to-day maths. So it is very simple. GT means greater than, GE means greater than or equal to, LT means less than, LE means less than equals to, EQ means equals to, NE means not equal to. So just keep in mind. So just note this operator GT, GE, LT, LE, EQ, and NE, and what is the meaning of that operator. So whenever you are working on condition parameter in JCL, this will help you. So here are some example. We need to read or understand this example, because I know the condition parameter is very confusing and most of the people get confused how to write the condition parameter. Just focus on each and every condition that we have in the example. So here condition parameter is condition equals to 4 GT. That means whatever the written code you are getting, it will compare that written code with 4. So whatever we are having as a true condition is always greater than 4. For example, if you get the condition code as 8, so the condition will check 4 is greater than 8, the condition is not true. That means your job will executed. If we get 0, that means 4 greater than 0, yes, condition is true, that means you need to terminate the job. So just keep in mind, whenever the condition is satisfied, we need to terminate the job. Whenever condition is not true, then we need to continue the job. So here 4 greater than, so that's why in the continue job column we are having the condition. So whenever your written code is greater than equal to 4, your job will continue. And whenever you are getting written code which is less than 4, this condition parameter will terminate your job. The next one is the condition 8 greater than. So for example, greater than equals to 8. So whenever, for example, you are having condition as 10, that means 8 is greater than 10, which is not true. That means your job will continue. 7, when we get the written code as 4, that means 8 greater than 4. Yes, condition is true. That's why terminate the job. So whatever the written code are greater than 8 are not true. That's why your condition will is not true and you will continue your job. And if whatever the written code are less than equals to 8, the condition will get satisfied, and that's why your job will terminate. So just go through this example one by one and try to understand. If you are having any confusion, then just write the condition on paper and just try to compare each and every value. Just take, okay, I'm comparing value 1, 2, 3, 4. Then you will get the better idea about this condition parameter and how this condition parameter works. So these are very good example. So I'll suggest everyone to practice this example by using pen and paper if you're having any confusion. So yes, these are some example of condition parameter on job statement. So this job will terminate if any job step has a written code of 8, because it will just compare condition code 8 equals to. So whenever you are having exact 8, then your job will terminate. And if you have any value other than 8, job will not job will continue to the next step. And here the job will terminate when the written code of 8 or a written code of 16 or greater. So here you are having two conditions. We can also use two condition, three conditions as well. So here first condition is your condition code should be 8, then your job will terminated. Or if you are having a written code less than 16, then your condition is true, then your job will terminate. So these are some good examples that you can study regarding this condition parameter. So that's it for today. So what we have learned about the completion code, written code, how those condition and completion codes are important in the JCL. And after that, we learn what is the restart statement. So how you gonna restart your job if that particular job statement is failed. And after that, we work or we check the condition parameter. So in your next session, we will be doing some practical regarding this written code. So I'll be showing what are the written code and how you get that written code. And after that, we will check the restart statement or restart parameter in practical JCL. So we'll be having some JCL and we'll be having some steps, and after that we can use the restart parameter, and after that we will be doing some practical on the condition parameter, so that you will get the better idea how the condition parameters are used. So that's it for today. Thank you so much.